Hi friends, welcome to our channel. Here we look at problem 3510, minimum pair removal to sort array. So this is a follow-up problem for problem 3507. Here the problem size is larger, right? Because if you see the nums, its have length can be as large as 10 to the power 5, right? So here we are going to solve this problem using SortedList. And actually, you can also solve it using heap. So here this problem is very suggestive, especially if you look at this. So select the minimum adjacent pair, right? And then do the operations, right? Do the replace operations. So here I'm going to quickly go over example 1 in order to do know what we are going to do. So here, if you look at the first step, so it's not a non-decreasing sequence yet in the sense of this problem. So then we can locate the smallest pair, and then we replace this by their sum. So we're going to do 5, 2, 3, 1. But this one we replaced by their sum. So here we shortened the length, but in reality, if you want to solve this problem, you might just keep this one to be 1 or make it none or something else, right? Just to know, right? Either the location of the minimal pair. For example, this minimum pair, the start index will be 2. The end index, will be 3, right? So then if I shrink them to be 1, so I just need to know, so what's the left? The left of the start or end. Left would be 1, right? Right. So if you join this one, the left will be, the previous one will be 1. And what's the right? The right will be the next of left. So you can use 4, right? But 4 is out of bound, but you can still use like this. So next time, so you just need to, so if I consider pairs, so 4 should be sum with 2, and the next pair will be 4 sum with respect to this index, but it's out of bound, so we cannot further do the pairs, right? So this is the one, right? You get this, and then you do again. This is not so you're going to 5 and 6. But in this so again you can leave the others, right? But you just need to know because in the second case, so we know the left will be 5 and the right still be 4, right? So we want to implement this procedure without changing the length of this array. So next we are going to do the coding, and in between we are going to explain the logic. And you can first try one time to see if you can follow the explanation. And then after finish the coding, we are going to do some print. Then you are going to understand the state of the variables involved. So with that said, let's do the problem. So here I changed nums to be capital A. So this is just for convenience of typing. So first I'm going to get this length. And then I want to use L and R to retrieve the left and the right of each element. So this is like a doubly linked list, right? You need to know what's the previous node and what's the next node. So here you can think each of the index corresponding to a value. So the previous index will corresponding to L. So for example, Li will be the left node index of the I, index I. So Ri, let's see, left I will be the left node index, and Ri will be the right node index. Hopefully you can have this intuition based on our solution to problem 3507. So now let's see. In this one, we're going to do this. We can list range, so we can start from -1 to n-1. And for the right, we shift right to be 1, so n+1. So if you print out this, print the L state, let me write like this, L, and then the right state So you will see. So originally for index 0, the left will be -1 and the right will be 1, right? So similarly for example, for index 2, the left will be 1, the right will be 3. Well, for index 3, the left will be 2 and the right will be 4. You can imagine we have a student node in the right. So with that said, let's look at the problem logic. So the main thing is that we do this shrinkage. So we are going to first get the number of inversions. And inversions is sum of AI. So if AI is strictly greater than the next one, right? So this will introduce a inversion. So for I in range, so because we use the I plus 1, so we should stop at n minus 1, right? So this is the one. Or you can do this. n minus 1, the previous one is greater than the current one. But then this way, the I should be start from 1 and ending at n minus 1, right? So this is the one way to write this. Also, we have a sorted list. So we are going to use sorted list. So this sorted list actually is inside the sorted container class. So you can actually also do this to specify from sorted containers import, say, sorted list. But in leetcode, so you can directly call like this. So here, what we do, so we store what? We store the pair sum. So let's say AI plus AI plus 1, and we also start the start index, right? So this is the for I in range. So we can start from 0, right? So but we should end before n minus 1, right? So we have this. So we can print out this. To see, right? So we know, so this we have 7, the start index will be 0, right? And we have 5, the start index will be 1. And we have 4, the start index will be 2, right? Because we are in a sorted container, so the one corresponding to the smallest sum will be in the front. But if you have 2 4s, but you have a larger index, the smaller index will be in front, right? So here we are using the default comparison key, right? So now we have this one. So next, we want to define 2 functions to do this operation. So here we define a add. So first we want to modify the number of inversions. If the number of inversions is 0, it means that the array is already non-decreasing in the sense of this problem. So also we want to define a remove. So both returns nothing but modifies this 3 LR and number of inversions. So for this, I'm going to write these 3 pieces in the same place. So this is 3 mutable objects, right? So this guy, so it's going to get us to get the smallest sum and the corresponding index, right? So now let's look at the add method. So because we want to modify this n inversions, so notice that this one is a integer, right? So it's immutable. In order to modify that, you need to non-local that variable, n inversions. So similarly here, I'm going to copy this one here. So now, in order to do the AND, so we need to know the next node, right? So you're going to call JRI, right? And then what we do is if it's inbound, so meaning that you can do this addition add operation. So I less than j less than n. So the sorted list will be add this one. So because we are adding a tuple, so AI plus AJ, right? So notice that I and J, their difference may be not 1, right? because if we do some shrinkage, right, shrink the pairs to be one number. So then the start will be I, right? So also this inversion might be changed, right? So n inversions is going to be add. So if AI is greater than AJ, right? So if AI is greater than AJ, right? So then you have this sum. You replace it by AI and AJ. So this yields a inversion. So this finishes the add operation. So now let's look at the removal operation. So we want to remove, see, let's also use I, right? A index. So also I get the J is right, the next, right? So then if 0 less than I less than J less than N, in other words, inbound, then I'm going to use discard. So because discard, if the element is not in the sorted list, it do nothing. But if you use remove method, you need the element to be in the sorted container. So this discard method is very elegant, see. So then what we want to remove is AI plus AJ, right? And then the starting index will be I. Then also we need to modify the n inversions, and it's going to minus. So if AI is greater than AJ, right? Because we delete this one, so you're going to decrement by 1. So this will be the two hyperfunctions. Of if you you can also choose to implement this piece in a class and then use this as a methods. But here I just list these 3 mutable guys here and then do the modification using add and remove. You can understand this add and remove as 2 workers to modify this R, L, and N, right? So next we are going to look at the problem logic. So for the problem logic, first we get the answer to be 0, so the number of operations needed. And then the while loop, if n inversions, if this is greater than 0, it means by now the list is not non-decreasing yet. So first we get the total, the pair sum, right, and the I. So it's going to be pop. So we need to pop the smallest one, right? And then we have this index, right? So for example, in this case, let's use this one step. So we have 0, 1, 2, 3, right? And then now the I is here. So the I is 2, right? So what you do, you first find the J. So it's Ri. So in this case, J will be here, right? And then what do we do? So then we get the H and the K, the J, because we are going to shrink this guy to be the same. So K will be 4, right? Notice 4 is out of bound, right? And H will be 1, right? So we get this, and then what do we do? So H will be the let's see, L of the index I, the previous one, and K will be the next one for G, right? Then what we are going to do? So we are going to remove this pair, because we are going to shrink 2 and 3 into 5. So this pair is involved, it's altered, and this pair will be altered, and also this pair will be altered, because this will be these 3 pairs. So and you can imagine, you can think of this case still inbound. So at the index, this 1, 2, and 2, 3, and 3, 4. So these 2 pairs will, 3 pairs will be replaced because we have this one. So it will be 1, 2, and 2, 4, right? So this be replaced. This 3 should be removed, and this 3 should be added. So let's do the same. So first to remove H, and remove So when we do remove, actually we do two things. We discuss corresponding elements if they are in the sorted container, and also we change the inversions. Remove this I, remove this J, right? So we so then afterwards we are going to change the value. We change AI to be a increased, but this corresponding to replace this number here, so to be this to be 4, right? So this is I, right? So now what we do, so we are going to set the R of I to be this one, to be the next, because this is shrinked, so you can see it marked as star, right? Or you can think I mark this here as star, but I don't need to do this, right? And then you just need to set the next of I to be 4, right? To be HIG key, right? So then if k is less than n, right, I'm going to set the left, because now the next of this one will be I, right? So once we done this, then we can do addition. So we add this pair. This is corresponding to H and this I, right? So we are going to add H and I. So this finishes our procedure. And then we just need to return the answer. So let me first run the code, and then we are going to do some print operations so that you can digest the details. So here, let's see. I forgot one thing, I guess. So each time we need to, once we have inversions, I need to do answer incremented by 1, right? So now let's run it. Yeah, it passes the two cases. Now let's look at the generic case. Yeah, it passes all the cases. So now let's do something. We are going to do some printing operations. So how do we do this? So first I'm going to print out this. So this original L and R, right? So this is the original sorted list, right? And now let's see. We also print out. So here I can actually do something like this. So I introduce another studio variable called round. So the round will be 1. So then what we're going to do is print. So F. So the round will be round, and the current state of the sorted list, and then the state of the n inversions, right? And then after we do this operations, we get the print F. So the current sorted list. So let's say the sum. So then we get the I, and then we get let me write this I. So this is the HI, right? And J. Okay, right. And then I'm going to copy this one. So this is after removing HIG, right? So here is after adding hi. And I guess we can also get the see this a. Let me write another line. So we can also monitor this C, L, R, and also the state of this sorted list, and also this A, right? So now I'm just going to get this. Also print it here. And then what we do is round is incremented by 1, and also let me add a print operation. So now let's using this example to see. Right. So originally you can see the index 0, the left is -1, and the right is 1. Right. So the original sorted list is something like this. So when we do the first round, so this is the state, and this smallest sum is 4, right? And the index is 2. There are 2 inversions, right? And then we can I is 2, and H is 1, J is 3, and K is 4, right? So then after removing this Hij, so total we didn't change yet, so it's still this state. And then this is the state of L, right? So then after you adding H and I, so you see the L. So for index 2, so the right is 4, right? For index 2, the left is still 1. And then, so because you have, you're going to add, so you have 6 1 that's added, right? Because you add H is 1. 1 corresponds to this 2 plus the next is already changed to be 4. So 2 plus 4 is 6. 6 at index 1. So you get this guy, right? You get a 7 5. You see this A is 5 2 4 1, but I don't care about this 1 anymore. So if you like, actually each time if I is inbound, so you can do something differently. Like here, you can change this AG, say to be some none, right? So if you run it, you are going to get something like this. So this way you make this none, right? And then after you do it again, so you know the H corresponding to 0, I is 1, and J is 2, and the K is 4, right? And then after you do this removal, so the I equals 1 also corresponding to index 4. So in this case, so you are basically doing this. You are doing in the second round, so you do this one. You add these two together. So then the corresponding state will be something like this. And in this case, you know, after this modification, 5, 6, and none, right? So actually, if you do one more, because now you have no inversions, you don't continue, right? So with this slide, I guess hopefully you get the idea. So for this problem, it's a hard one, and indeed, it involves some advanced data structure. So in this video, we solved it using SortedList. A good practice is that you try to solve this problem using heap, or you can follow our videos for a solution using heap. So this is the one comment. Another comment is that for this kind of problem, in order to genuinely digest, you should do a detailed walkthrough by yourself. So here, let me delete this line because it's not necessary. We don't need this operation. And meanwhile, I'm going to keep this print here so that you can try by yourself to help you understand, right? So with that said, I guess that's the second comment. The third comment is that we have a number of playlists in our channel. There are lots of problems. You're welcome to check out those videos to do the practice. With that said, that's it.